Sorry. Hello, good morning to everybody. Uh, Welcome to this webinar today. I would like to share my webcam, but it seems it doesn't operate, so sorry for the problem. Okay, let's start with this webinar. 30 minutes today, but we will talk about the main and key aspects in the installation of pressurization systems. So let me introduce. My name is Santos Bendicho. I am the head of the Smoke Control Projects Department. And I would like to thank you for being here today. Okay, so the table of comments that we will see today will be those. We will see which is the pressurization system performance. Then we will see the spaces to be pressurized, the system components. We will make very briefly how to calculate using our quick fund software the pressurization system, and we will make a revision of those systems that we can use. And later on, if you want to make some questions, we will try to answer. Okay, so regarding the pressurization system performance, the main point is to clarify what is the objective of such systems. First, we have a system that we use to maintain the free of escape roads free of smoke. So by blowing air into the pressurized space, what we call the protected space, in green on the left, on the right, sorry, and in order that the air that leaks to the unprotected space in red leaks through between the gaps that we have between the staircases. Come on. Between the staircases and the sorry, between the staircases and the protected area. So to maintain this level of overpressure, 50 pascals typically according to part 6 or 30 pascals according to the new part 13. And in case of opening the door, when someone opens the door, it is not possible to maintain this level of overpressure, then the goal is to maintain a certain level of minimum air velocity to avoid the air penetrating in these protected spaces. But be careful that we maintain this higher flow that required for the door open condition. If we maintain constantly during other situations like door close situation, then is the risk that the overpressure in the staircase is too high, and these do not allow to open the door against this overpressure. So we have to control this level of overpressure with a minimum overpressure to avoid the leakage of smoke into the staircase, a maximum overpressure to allow the doors to be open, and sufficient airflow in the door open condition to maintain this minimum critical velocity. Typically, the airflow in the door open condition is the highest one, so it's the one that defines the situation, the requirements for the pressurization system, but the system will need to adapt the airflow to adapt to the changing situations between door close and door open condition. Let me show you a video trying to explain how the system operates. If we have a building with both lobbies and staircases pressurized, in that case, then we have the units on the roof providing fresh air in case of fire. We can also use these units for ventilation, day-to-day ventilation. Okay, we have the fire brigade control panel at the entrance of the staircase, and we have the grills or dampers to provide fresh air both in the lobbies or in the staircase, pressure sensors to measure and control their flow according to the situation on the evacuation route. So when there is a fire, so the first point is that the smoke detection system is activated, and from the fire alarm we receive a signal in our control panel that activates automatically the pressurization kits, opening the motorized dampers on the roof, providing fresh air to increase the pressure difference, as we see here in this manometer, to 50 pascals typically in the door closed condition. and to maintain this overpressure in the lobbies during when the doors are closed. But when the door is open because someone has to evacuate, then it's not possible to maintain this level of overpressure. The overpressure decreases, but we need to increase very quickly the airflow to provide enough airflow to avoid the smoke going again into the staircase. Okay, when the door closes, then we have to modulate the airflow again, reduce it to maintain this maximum level of overpressure or level of overpressure control in 50 pascals. This is our kit box PDS that we will use to make this control. Okay, once said that, once explained how the system works, let me explain the key aspects that we have to take into consideration in such those systems. The first one is which spaces has to be pressurized. There are differences between the Part 6 and the Part 13 that both are used depending on the country for the design of the pressure differential system. But in any case, there could be the necessity of pressurizing the lobby or not. We will see the cases. Always has to be pressurized the staircase, but about the lobbies, in some cases it's necessary to pressurize or in some cases not. So when we need to pressurize the lobbies, we have two options. One is pressurizing all the lobbies at the same time with a constant capacity fan designed for the total capacity of the addition of the airflows required for each single lobby. So imagine that we have 1,000 kilometers per hour per lobby, then we need a fan and a DAC for, in that case, for 5 times this airflow. So depending on the number of door levels that we have, this airflow could be huge, and then the required space for the DACs to provide pressurization for the lobbies could be too much for the building, and then it's necessary or it's convenient to use system pressurizing only the lobby in the fire level. In that case, what we need is pressure sensors on its lobby. In that case, pressure differential sensors connected Modbus with the main control panel, or these individual PDS lobby controls that are secondary control panels that can also read the pressure difference between the lobby and the non-protected area where we have the fire. So these systems has to be activated from the fire alarm, and once they are activated, they can send a signal that they are reading to the main control panel to modulate their flow required in this lobby. We will have a second unit to pressurize the staircase with its own pressure differential sensor. In any case, as we have mentioned, it's one of the most important things is that we are with a system that is designed for different situations: door open condition with a higher flow, typically door closed condition with a low requirement of airflow, and we have to modulate their flow in or to control the overpressure in such conditions. The standards gives different solutions like dampers opening outside, barometric dampers, let's say, dampers in DACs, also barometric dampers to create a bypass, but the most common system used is by controlling the velocity of the fan, so the flow that is provided by the fan through the lecture of a pressure sensor reading the pressure difference in the protected staircase. So we have a pressure sensor that sends that signal to the inverter, and the inverter modulates the velocity and so the flow of the fan. So in the door closed condition, where we have to maintain this 50 pascals in the old Part 6, 30 pascal in the new Part 13. Okay, what we do is to reduce the airflow by reducing the velocity, so modulating this fan speed. Again, when we have this situation when we open the door, as the pressure differences in the staircase drastically decreases, we need to increase the velocity, because the pressure sensor will be reading, for instance, 10 pascals, and will say to the inverter, okay, I'm reading 10 pascals, and the inverter will say, okay, but I want to have 50 pascals, so I have to increase the velocity, and so increase the velocity, increase the flow, and then the pressure sensor, due to this increase, say, okay, now I'm reading, let's say, 20 pascals, the inverter says, okay, but I need 50, and continuously all the time increasing the velocity till it reaches maximum velocity, typically 50 hertz, and provide the maximum airflow. This is important to take into account, and this is also considered in the 12.101 Part 6, where it's written that when we work with variable fans controlled by pressure sensors, we need to ensure that the system is able to provide 90% of the airflow in less than 3 seconds. Okay, in the new Part 13, it's slightly different. It's say that when the door is open, the system has to react in 5 seconds, or when the door is closed, let's say that the system has to provide the new situation, so the maximum airflow in 5 seconds, or the nominal overpressure in 5 seconds also. But the Part 13 also came together with a revision of the Part 6 from 2022 that allow to test the kits in the laboratory. In that case, what requires is to increase this, provide again this 90% of airflow in 3 seconds and provide 120% of the nominal pressure in less than 3 seconds also. In any case, what we will have will be that in the door closed condition, we'll have a low amount of airflow that will blow. Okay, here in blue we have the airflow, in orange we have the pressure difference, and this will be the position of the doors. So while the doors are closed, we maintain the pressure difference control by blowing a little amount of airflow, but when the door is open, as the pressure difference drops, so we have very quickly to increase the airflow. So the system has to increase this in these 3 seconds. Again, when the door is closed, then we are blowing a big amount of air that it's passing through a small area because the door is closing, and then we have a peak of overpressure in the staircase, and this will be dangerous because this will, during this time that we have this peak of overpressure, people will not be able to open the door. So that's why this peak of overpressure is limited again to 3 seconds. Okay, so that's why the system has to react, and that's why we need very specific systems that are, let's say, not only provided by inverted, but by PLCs and with specific components to be very reactive to the small changes in pressure difference to very has a short time of reaction. The second point that it's important to consider in the installation of a pressure differential system is the need of a standby fan. It was written in the old Part 6, this requirement when we have a building with only one staircase. In that case, as we only have one staircase, if this is main fan will fail, then we will have the problem that this staircase could be full of smoke. So that's why in that case is required this standby fan. We have 2 options. One is installing parallel, okay, with backdraft dampers in order to avoid a bypass, or installing series. In that case, we have to be careful because we have to consider the additional pressure drop that the fan that is not operating creates to the fan that is operating. So we need again control systems that, in case of detecting the failure of the main fan, automatically reacts and activate the standby fan. Okay, this requirement is not written in the new Part 13 for design of pressurization system, but even though we consider that it's even though it's not mandatory, we consider it's a good requirement, and in fact there are many countries where even not being mandatory, it's considered as a good practice. So we always recommend that. Third point to consider in the design of a pressurization system, very important also, it's the risk of avoiding that the air intake that provides fresh air to the pressurization system is affected by the smoke. So the first point is that the air intake shall be always located away from any potential fires. So mainly the main point will be that the first approach should be to place these air intakes, so the pressurization kits in the ground level, okay, to avoid contamination by rising the smoke going outside through the facade of the building. In that case, if it's not possible, then they have to be positioned it in the roof. But in any case, if we put it in the ground, even though the standard requires that we have to provide a smoke sensor to close the system in case of detecting quantities of the smoke in this inlet. So even though installing this unit in the ground, it is necessary to provide a motorized damper together with a smoke sensor, so that in case of detecting the smoke, the damper will close and the system will be stopped. In addition, if we put these systems in the roof, the situation is more critical because there is the risk that the smoke going up from the facade arrives to this inlet. That's why both standard, in this case Part 6 and Part 13, requires the necessity of having 2 independent air inlets directed to different facades of the building, and both with motorized damper and smoke sensor, so that the situation that we will have is that we'll have both the smoke sensors, both dampers initially open when the system is activated, but in case of one of air intake being contaminated by the smoke, we will close this damper, but the other, the alternative one, will remain open. So the pressure differential systems should have these air intakes dampers with smoke sensors. 4th point, always not consider, or many times not considering the design. So let's say that during many years it has not been considered. So we have been focused in many projects in the pressurization part, but not in the air release. But during operation of the system, the air that from the pressurizations will flow from the pressurized space to the accommodation, both in the door closed condition or in the door open condition. In the door closed condition, this pressure difference between both sides is achieved thanks to the airflow that leaks through the gaps between mainly the door and the ground. So if we don't have this leakage of air, let's say, we will not have this pressure difference. So if from the non-protected area we don't have air release, so if it's a completely tight area and air cannot escape, we will not have this pressure difference, and so on, the smoke will leak in the protected area. The same when in the door open condition. If we don't have this door open, then the air will not pass through this door, so again the smoke will go into the staircase. So that's why it's necessary this air release into from the non-protected area. This we can see with this CFD analysis that we carried for a specific project here in Spain. In that case, where we analyzed what happened if this air release is not present in the non-protected area. In that case, we see that after 120 seconds, even with the door closed, but especially with the door, if the door is not closed, but even with the door closed, it starts to leak some smoke into the staircase at 180 seconds. The level where the fire is, it's full of smoke. Then 240 seconds, we have 2 levels, etc., etc. So if we do not have this air release, we do not have a pressurization system. The system will blow air, but this air will not maintain this pressure difference, will not maintain this velocity in the door open condition. So at the end of the day, the staircase will be full of smoke. Later on, we see that at 500 seconds, when the window breaks in the accommodation area, then we have an air release thanks to this breakage window. Before we didn't have it, but when the window breaks, we have this air release. And so we can see also how in the last images, how the system, the pressurization system, is able to clean very quickly to clean this staircase thanks to the combination of the pressurization system and the air release. So that's why it's necessary to provide this air release in our systems. In that case, we've made the same simulation considering that there was air release in the accommodation area, the fire room, and then we see that non-smoke is going into the staircase. So the staircase is all the time during all the simulation free of smoke, allowing the evacuation of the people and the intervention of the firefighters. This air release, we can do it with different solutions. The standard says that we have as a first option the installation, the provision of dampers or vents or motorized windows in the facade of the building. In that case, if these openings can be affected by the wind, we have to provide in 2 facades independently. Okay, and the second point is that we have to open these windows, these dampers, in the fire level, in the level where the fire is. To do that, we need these control panels on its lobby, so that again they measure the pressure difference in the fire level to send the signal to the main control panel, but they can also manage the opening of the motorized damper in this fire lobby, in this fire level lobby, let's say, but they can also manage the opening of this air release window in the facade. Okay, so with this control panel, we can control all the components, not only the pressurization part, the supply part, but also the air release part of the pressurization kit. Second option that we have is providing a natural ventilation duct communicating all the levels, provided with a motorized damper on its level. Again, this motorized damper has to be open only the fire level, but on the other levels they have to remain closed. And then these dampers can also be controlled by this PDS lobby control, this small control panel installed on its level. So other points to consider regarding these dampers, if typically we will have these levels will be, it's one fire compartment, so typically this will be fire rated DAC, okay, and these dampers are smoke control dampers with multi-compartment performance. We are not talking about fire dampers, because fire dampers should be all closed in case of fire and are used in ventilation ducts. When we use in smoke control systems, we have another product that is the smoke control dampers with two possibilities: one multi-compartment with this EI classification to avoid the risk of propagation of fire, or in case that this is not, these levels are not, it's one fire compartment, then we can use a single compartment smoke control dampers. Or we can, at last option, do it with mechanical extraction, okay, providing a smoke extraction fan connected to a DAC, again, smoke extraction DAC, multi-compartment or single compartment, depending on if we have to maintain the compartmentation between levels, and connected to smoke control dampers, single compartment or multi-compartment. Okay, about the last point, about not the last, but yeah, the last point will be the activation of the system. So first, we need a smoke detection system that sends the signal to our main control panel to activate the pressurization kit. And once the kit is activated, it's completely autonomous. He can give outside signals to communicate the state of the pressurization system. But it's once the fire is finished, we have to reset the pressurization kit. Typically, these kits are activated by this addressable smoke detection system, but if we have a building without the new renovation of a building and we don't have such a smoke detection system, it is possible to install independent smoke sensors on its level that will send a signal to this PDS lobby control that we have seen in the previous slices, and this the proper control panel in the proper level will be activated, and again will send the signal for activation to the main control panel or of the kit box PDS. Second point about control is manual control of the system. It is always necessary to have this manual control for the firefighters that shall be located in the main exits or close of the building entrance, and so that fire brigade can control this system. There are different possibilities, but the minimum that the Part 13 require for these systems is to provide an automatic manual switch, okay, typically with 3 positions, 0 manual or automatic. The system, if it's in its normal situation, it's an automatic, waiting for receiving this activation signal from the smoke detection system. But it's possible for the firefighters, if when they arrive the system has not been automatically activated, they can manually activate, or even they can deactivate if they prefer. This is the minimum requirements in terms of activation, and in terms of information, the standard requires minimum these 4 lights: green light indicating that the system is supplied with energy and it's ready to be activated from the smoke detection; red light when we receive the signal from the fire alarm and the system is activated; then white light when the system is running; and an additional yellow light to indicate any failure of the system. There are different possibilities, but we have systems very simple with these 4 lights and with this main switch. But the main kit box PDS, that is the recommended system, also includes a touchable screen with all the information of the system, where the fire brigade can read how the system is operation. They can read the level of overpressure. They can read if there is any presence of smoke in any inlet, etc., etc. Okay, last point to consider about key points about pressurization system is for high-rise buildings. Okay, typically for standard buildings, we can, let's say, the standard gives general provisions for the design, but for high-rise buildings, we have to consider that there is the risk of the stack effect, because due to the temperatures, different temperatures inside, outside of the building, there is a possibility that the higher parts of the staircase have higher pressures compared with the low parts of the staircase with low pressure. So there could be leakage of air from the protected area to the accommodation areas, or the opposite, depending if we are talking about winter or summer. In any case, this is something for specific designs that we can take into consideration, and the system could require the need of several overpressure kits to control this different sorts of pressurization, higher part and lower part, or 3 or 4 different parts. Maybe reversible overpressure kits to extract air from the upper part of the staircase if due to the stack effect the overpressure is even higher than the maximum to allow the opening of the door. And also maybe multiple differential pressure sensors distributed along the staircase connected to the overpressure kits to choose if we want to operate with the average value, maximum value, minimum value, or some specific value of overpressure. For the calculation, we have our QuickFan software that you can download for free from our web page. When we have this tools area, where it's an specific area for stairwell pressurization calculation, and where you can calculate both according to the part 6, EN 12101 part 6, according to the new part 13, EN 12101 part 13 from 2022, and even though if you require according to NFPA 92. There are the 3 possibilities. It's possible to use this software for this 3 calculation, and we can select the class of system of our building to adapt to our design. For this, I recommend in our YouTube channel we have also microlearnings specifically talking about how to use this tool for calculation of pressurization system. So you can go there and follow these specific trainings. At the end, what we obtain is the flow in the different situation, door closed condition, door open condition, and a resume of the airflows in these situations with the schemes of each floor. So to finish and to cover all these requirements, all these key points that we have seen, we introduce our Kitbox PDS Smart. That it's the most developed system that we have. That it's developed first to achieve this 90% of airflow and this fast reaction, let's say, in the door closed condition and the door open condition in 3 seconds, with also a test for certification of this dynamic performance with electromagnetic compatibility and environmental resistance test. And so you have this to prove that we can provide this fast response of our system. Mainly, the system is also provided with batteries for the control panel, certified, allows a quick setup of the system with possibility of working with till 3 intakes with smoke sensor. The smoke detector has automatic reset, so we can, if we have detected the smoke in one inlet, we can reset and check after some time if the smoke is still present or has disappeared in order to reactivate the system. We can work with pressurization or depressurization, and in case of pressurization, also with the possibility of extraction mode to extract the smoke after the fire. We can connect multiple pressure sensor Modbus with a control panel to operate with an average, the minimum, or the maximum. We can connect external sensors, humidity, temperature, to activate the system for day-to-day ventilation according to the temperature or humidity conditions, or we can include a timer to program the day-to-day ventilation. The system, of course, can be connected to the BMS of the building to have all the information of the system. The control panel is in 2 parts. One main control panel with all the PLC, inverter, and all the electromagnetic components to manage this operation of the system, but additionally a fire brigade control panel with these 4 lights, these switches for manual automatic activation, and also a test selector to activate the system for maintenance and to check that the system is operable in any case. And the system can be connected with this PDS lobby control on its level to be activated in the fire level, so to read the specific pressure difference on its level to send to the main control panel to modulate their flow for this specific pressure sensor. And this PDS lobby control, remember that they can also manage the operation of the motorized damper to provide airflow in the specific lobby in the fire level, and also activate the air release damper or window in the level where the fire is present. Also with the possibility of operating proportional dampers to control overpressure with a proportional damper. The activation can be done through the main addressable system of the smoke detection or with independent smoke sensors installed for such function. And to finalize, the damper, the kit also includes these damper spokes connected initially with one, but an additional one, if we need to put in the roof, can be provided. One of the main points of these dampers is that they have to be very fast. They open and close in 2.5 seconds, so that in case of detecting smoke in the smoke sensor, very quickly the damper stops, close, let's say, and stops the fan in order to avoid the smoke presence in the staircase. So that's all from my part. So now, if you there are some questions, it's time for you. I would like to connect my webcam, but I don't know if it operates. I think no, maybe now. Okay, so if there is any question that you can put the system. There is a question, let me see, about well, there's one question saying sometimes I receive pressurization requests about projects where installing the board is not possible due to space limitations. Is there any way to pressurize using ductless systems? Well, about the use of ducts of pressurization in the staircase, the part 6 requires that if the building has less than 11 meters, you can do only providing only one supply point. If the building has more than 11 meters, you need one supply point. It's 3 levels, so that you will need duct in the staircase, and of course you will need ducts if you have to pressurize the lobbies. But regarding the staircase, you have this limitation in the old part 6. In the new part 13, there's not such limitation. Let's say it's possible to do as the designer prefers, okay, and leaves this in the hands of the designer or the installer, who has to prove in the commissioning that even without having this uniform distribution of supply points, you can achieve the level of pressure. So if you install the system, you test it, and you prove that in all the levels you achieve the minimum pressure difference and the required velocity without ducts, lucky you. If you, after commissioning, you cannot prove it, then you have a problem, because then you will need to install ducts and solve the system. So it's open in that case in the part 30. How to calculate required release airflow? Okay, the required release airflow will be the airflow passing through the door opening between the protected and the non-protected space. Typically, this is lower than the airflow that the fan supplies, because in addition, when we have the door open situation, in addition to the airflow that is escaping through this door opening in the fire level, we have also additional leakage through other levels, because as a consequence of this air passing through this door open, there is let's say a remaining overpressure in the staircase, typically 10 pascals, and then due to this remaining overpressure in the other levels, there are some additional leakage. So to resume, you have to calculate the area of the door in the door open condition multiplied by the required velocity. In the old part 6, we have 0.75 for classes A, C, D, or E, or 2 meters per second in classes B or F. In the new part 13, we have for class 1, 1 meter per second, and for class 2, 2 meters per second. Okay, so you multiply the required velocity by the area of the door, and then this is the flow that you have to evacuate to this air release. To dimension this air release, if it's a window, the standard requires 2.5 meters per second. Okay. If it's a natural duct, it's 2 meters per second. Okay, next question. Can we use the elevator shaft as an air supply channel if it's in the same roof as the stairwell? Well, difficult to say, Carlos. Theoretically, yes. Okay, will be a possibility. Okay, but then you will need, I suppose, you will need some some grills between this elevator shaft and the staircase, because you cannot consider the leakage from through the doors. So you will need to put some grills in the wall between the elevator and the staircase, I assume. And maybe depending on the country, the elevator shaft should be requires a fire compartment. So it could create a, let's say, a situation conflictive. Theoretically, yes. We should analyze if there is additional requirements for fire compartmentation. And again, if it's in a standard lift shaft, let's say, then you need to consider the provision that taking the elevator, put it in the ground level first before activating the pressurization, so that the air passes, let's say, free through this duct that you will use for as a lift shaft. Can be a solution that can be installed, but in some countries it's not possible to have also this elevator shaft in the same room that the staircase. Okay, more questions. I have seen that my colleagues has been able to put the copy of the presentation on PDF, so you can download. So in any case, you will have this webinar has been recorded, so you can see it again how many times you need. And I remember that in our YouTube channel you have a record of all the webinars that we do. And so, as we don't have some more questions, we will finish here this webinar, reminding you that we have a provision of doing 2 more new webinars, one microlearnings, one for the use of dampers, small control system provided with dampers with insulation for efficiency of the systems, and a second one that will be according the small control system for freezing rooms with our fridge flat damper, specifically designed for such application. Please follow our mailings, remembering you these new webinars that we will follow after that. And if you have any additional question after this webinar, or anything you want to make us, you can send an email to us, and we will respond as fast as possible. Thank you very much, and thank you for attending. I hope this has been interesting for you. Thanks a lot.